Okay, today we're going to be talking about probability. Actually, all of Chapter 5 is probability. It starts out pretty simple and it gets very complex. So make sure you're looking at the examples in the book. They will help you be successful. So if you read this, it says, the meteorologist forecasts a 60% chance of rain. A new drug is reported to have a 0.5% chance of causing headaches. You have a 1 out of 4 chance of guessing the answer to a multiple choice question if it has 4 possible answers. All of these statements have one thing in common. They attempt to predict the future. In mathematics, you can use probability to determine what may happen in the future. So, these are some of the things we'll be finding out about in 5.1. So let's get. A probability experiment is an action or trial that has varying results. The possible results of a probability experiment are outcomes. For instance, when you roll a 6-sided die, there are 6 possible outcomes: 1, 2, 3, 4, 5, or 6. A collection of one or more outcomes is an event, such as rolling an odd number. The set of all possible outcomes is called a sample space. So let's look at a kind of example called a tree diagram. So here we have a pizzeria, and we're going to put all the possible things that we have. So each of these is an outcome. Someone may choose a square. They can choose a thick or thin, large or small, pepperoni or mushroom. So these are the outcomes. The event is what someone chooses. Okay, a collection of one or more events: a square, thick pizza, large pepperoni. Okay, that is an event. This is your sample space. This tells you all the possibilities. Okay, the set of all possible outcomes. So this is your outcome. This is an event, one set of outcomes, and these are your sample space. So that kind of puts it in a much clearer format. Okay? All right. So in exploration number 2 in your journal, you're going to find the sample space of an experiment. So list all the possible outcomes in the sample space of an experiment. 1 6-sided dice is rolled. So obviously the answer for this one is just 1, 2, 3, 4, 5, 6. But what are the possibilities if we roll 2 6-sided dice? This is where you have to think a little bit more. So here's what the answer would look like. This is the first dice, and this is the second dice. So we're going to put 1 and all of the possible outcomes for dice 2. Okay? Then we would put 2 for the first dice, and then all the outcomes for dice 2. So you can see there is a lot more possible outcomes once you add the second dice. Okay, before we do this slide, I want to go over how to write a probability. So the first thing you need to know is you think of it as the numbers you want, the number you want, over, divided by, the number of possible outcomes. Okay, so look at this one. Consider the days of the week. Suppose the days of the week were written on a separate piece of folded paper and stuck in a bag. Okay, so here's our bag. And we're going to put Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday in the bag. What is the probability of randomly choosing a day that begins with the letter S? So what are the total possible outcomes would be 7, because there's 7 days of the week. How many days of the week start with S? So we've got 2. So our answer here would be 2 out of 7. What is the probability of randomly choosing a weekday? Your total again is 7, but now we have 5 possibilities. Okay? What is the probability of randomly choosing Wednesday? Again, we have 7 possibilities, but there's only 1 Wednesday. What is the probability of randomly choosing a day that is not Sunday? Again, 7 possibilities and 6 days that are not Sunday. So hopefully that helps you understand that concept a little bit better. All right, so list the possible outcomes for this situation. Flipping one coin, says A, 3 times. So I just put these here just so you could remember you're flipping it 3 times. So one possibility would be heads, heads, heads. This is just one of the possibilities shown here, but here are all of the possibilities. So 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possibilities here. What is the possibility of 3 heads? It would be 1. Okay? So just think about that and think about all the possibilities. If it was 2 heads and a tail, then it would be 1, 2, 3. So it would be 3 out of 8 for 2 heads and a tail. Doesn't matter what order we're not talking about order now. Okay, here's another example. Spinning a spinner twice that contains 4 equally likely colors, blue, red, yellow, and green. So, what are the possibilities? Okay, think about what they are. Spinning the spinner mentioned in exercise 2, followed by flipping a coin once. So you've got to come up with all the possible outcomes. Okay, that's for you to do. We can talk about that later. But remember, you've got blue, red, yellow, green. Okay, you've spinned it twice. That's if you've just got a different color every time. Or you could get blue, blue, yellow, green. Or blue, blue, red, green. So there's a lot of possibilities. So I want you to try this and think of all the possibilities. I'm not giving you the answers here. Okay? All right. The spinner shown is divided into 4 congruent sections, and you spin the spinner 1 time. George and Maria each determined the sample space for the spinner. I think the sample space is shaded, unshaded. Okay? Maria says, I think the sample space is shaded, 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 unshaded. So who determined the sample space correctly? And explain your reasoning. So look at it carefully, and then here's the answer. Maria is correct. The sample space contains 4 items because there are 4 sections on the spinner. Each section represents a different outcome. So, read why the first answer is not correct. Okay, this is your exploration. So in your journal, so look in 5.1 for exploration 3. It says, in an experiment, a spinner is spun. How many ways can you spin a 1? Well, there's only 1 1, so there would be 1. How many 2s? 1, 2. How many 3s? 1, 2, 3. How many 4s? There's 2 4s. And how many 5s? 1, 2, 3, 4. So those would be your answers. List the sample space. Okay, it's 1, 2, 2, 3, 3, 3, 4, 4, 5, 5, 5. And what is the total number of outcomes? It is 12 because it's divided into 12 equal sections. So this is how many ways to spin a 1, a 2, a 3, a 4, and a 5. This is the answer for this one. Okay? These are the possible answers. Notice they don't have to be in the order that they are on the wheel. Okay, so then number 4 asks, if we look at exploration 4, it says a bag contains 2 blue marbles and 5 red marbles. 2 marbles are drawn from the bag. How many ways can you choose 2 blue? So there's only 2 because you've got 1, 2. A red then a blue. So there's quite a few ways because you have all these different reds. And so that are 10. This red with this blue and this blue, that'd be 2. So with each red, there's 2 possibilities. So that would be 5. Okay, a blue then a red, then there's only 2 possibilities. There's also 10 because you could do blue number 1 and then red number 1, blue number 1, 2. So there's also 10. And then 2 red. So that would be number 1 and number 2, number 1 and number 3, number 1 and number 4, number 1 and number 5, or number 2 and number 1 and 2 and 3. So you go like that. So here are all the answers to this one. So hopefully you figured that out. If you didn't, go through these problems step by step and figure it out. So this reflects these possibilities. Okay? Notice it also adds up to 42 here. All right, so these are total numbers. These are specific sample spaces. okay, is the sample spaces. So keep in mind all those different definitions. Okay, so this is just showing you all the possible answers, finding a sample space. So I just wanted you to see this. Using a tree diagram helps, or you could write it like this. So you can see there's lots of different ways for you to figure it out, but these are all the possible outcomes. Okay, so here's the 12 outcomes from the tree. Okay, then you've got this, still 3, still 12, or this. So I just wanted you to see the different ways that people could come up with the answers for that. Okay, so here's an example for you. I would give yourself pause and see if you can do this yourself. The answers will come up in a couple of seconds. There you go. Check your answers. All right, the probability of an event is the measure of the likelihood or chance that the event will occur. Probability is a number from 0 to 1. In other words, it is a fraction. But it also includes 0 and 1 and can be expressed as a decimal, fraction, or percent. So, when you think of a 50-50 chance, here's what it would look like. Okay, right in the middle. But if it gets to 75, or 3/4, 3 out of 4, then it's very likely. And it's 100% going to happen, certain, then that would be there. 0% or 0 would be impossible, and 1/4, 0.25 or 25% is highly unlikely. So, the outcomes for a specific event are called favorable outcomes. When the outcomes are equally likely, the theoretical probability of the event can be found by using the following. Remember, the theoretical probability is when you're trying to guess what the outcome would be. Okay, not an actual forecast. So the number of favorable outcomes, the ones you wanted, over the total possibilities. Remember we did this before, early on. So think about that again. The probability of event A is written as P of A. Okay, so finding a theoretical probability. A student taking a quiz randomly guesses the answer to 4 true-false questions. What is the probability of the student guessing exactly 2 correct answers? So here is, they find all of the possible answers. Okay, so we're going to count all those up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The number of outcomes is 16. That's the total, right? Then the ones where there's only 2 correct, doesn't matter what order, you can see that. It's specific to the order, but it's which ones you got correct. So it's saying incorrect, incorrect, correct, correct, then incorrect, correct, incorrect, correct. So they're showing you all the possible ways you could get 2 correct. And there was only 1, 2, 3, 4, 5, 6 of those. Those are our favorable outcomes because that's what we're trying to do. So the probability is 6 out of 16. And we would reduce that to 3 over 8. So the probability of the student guessing exactly 2 answers is 3 out of 8. Okay, and then it goes to step 3. They show here just like we just did. And so they could put it as 3 over 8. They could say 37.5. They would get that by dividing 8 into 3. Okay, and that would give them this, or it could be 0.375. So all of those answers are correct. Okay, so Bill, Larry, Irvin, and Kareem were playing a game with marbles. There are 8 blue marbles and 4 yellow marbles in a jar. Here is the question. What is the probability of randomly selecting a blue marble from the jar? And you can see that they all have different answers, but they all got a thumbs up. So let's figure it out ourselves. So the first thing we want to know is, what is our total number possible outcomes? And there are 8 plus 4, and we're only going to pick once, so that would be 12. And then we want to know, we want to figure out how many blue there are. Well, it says right here there are 8. So we're going to divide by 4 over 4, and we get 2/3. So now we can see, there's Bill's answer, there's Irvin's answer. 2/3 equals 0.6666, repeating, or 0.67. There's Kareem's answer. And then finally, we can turn that into a percent, 67%, and that gives us Larry's answer. So we can see that everybody got it correct because they all did one form of the correct probability. Okay, so now we're going to look at the probability of the complement of an event. So that is the thing not happening. So the probability of the complement of event A would be written like this, and what it is 1 minus the probability of A. So for example, if you look at the one we just did, what is the probability of them not pulling a blue? So we would go 1 minus the probability of A was 2/3, so it would be 1/3, or 30.33, or 33%. Okay, all of those are the probability. Now another way of doing that would be go back to your original equation. It was 12, and since not blue would be 4, we can see that that equals the 1/3. So here are the possible answers for that one that we just did. Okay, here's a more lengthy explanation, so if you want to read that, just push pause and read that. All right, so finding the probabilities of complements. So you roll 2 6-sided dice. Find the probability of each event. So the sum is not 6. So the first thing we want to do is find where is the sum of 6. And if you look really carefully, here is the sum of 6. These are the only ones that are 6. So we can see that the total is 36, and the sum is not 6 is 36 minus 1, 2, 3, 4, 5. So that'd be 31 out of 36. Or 1 minus 5 over 36. Either way, it's 31 over 36. And then you would divide 36 into 31 to get that percent. Okay, then we're going to change colors here and look at another one. The sum is less than or equal to 9. So we're going to go, okay, here's 9, but they want equal to. So these are the only ones that are not less than or equal to 9. Okay, these are all greater than 9. Okay, so 1 minus, so we would go, everything else would be again 1 minus 1, 2, 3, 4, 5, 6, 6 over 36, or 1 minus 1/6 equals 5/6, and there is our probability for this one. Okay, so you could have solved it by looking at all the ones that weren't, or you could do it by going one minus the other. All right, just different ways to look at problems. All right, so they want you to find this outcome. So remember, all you're doing is going 1 minus P of A, so 1 minus 0.45, and you're going to push pause here and see if you can get these. So give yourself a minute and then come back and the answers will come up. There you go. All righty. Okay, now the difference between a theoretical probability, which is what should it be exactly if everything worked as it should, and the experimental probability is you are doing the actual experiment and you're getting the actual answers. That is not, they're not always going to be 50-50 or 3/4 or whatever. You're going to get what you get. So looking at this, we got these results. Now that we have these results, finding the answers are very specific because we have our total, but we also have the exact answers. So the table shows the results for which color is the experimental probability on the color the same as the theoretical probability. So remember, since we have 20 and the theoretical probability would be for one color would be it should be 1/4, right? So that would be 5 times out of 20, correct? 5 out of 20 is 1/4. So the only one that matches that is the red. So let's look at their answer. Okay? And there shows you that red is the only one. Okay? Then it asks, for which color is the probability of stopping on the color greater than the theoretical probability? So we already determined that 5 is the theoretical probability, so green is the only one that was greater than that. Okay? So experimental probability changes because you get actual results, which you then compare to the theoretical probability in some cases. Okay, in the U.S., a survey of 2,184 adults aged 18 and over found that 1,320 of them have at least one pet. The types of pet of these adults that these adults have are shown in this figure. What is the probability that a pet-owning adult chosen at random has a dog? So the first thing we know is that our total was 2,184. However, that is not the total for this because it's saying that the pet-owning adult. So we're going to go with 1,328. These are the people that have pets. That's where you have to be careful when you're reading. So this is not the total we're talking about because this is all the adults surveyed. Okay? They want to know, surveyed, they want to know pet owners. So that is our new total. Okay? So be careful. And then we're going to put the 916 on top because those are the dog owners. And that would give us our total. Okay? So the probability that a pet-owning adult chosen at random has a dog is about 69%. Okay? So always reduce. Make sure you reduce the fraction. You can put it like that or as a percentage. Okay, so let's ask another question. What is the probability that a pet-owning adult, so now we know what our total is, it's 1328, owns a fish. So the fish will now be our numerator, 146. Okay, and then we're going to calculate that out, and we're going to get about 11%. So don't be afraid to look carefully. In fact, do be afraid not to look carefully. Make sure you're being careful. Okay? All right, a common error, confusing probability versus odds. So I thought this was really important that you understand this. To introduce the term and to distinguish the difference between the terms, use a simple example. The probability of rolling a 4 on a standard number cube is 1 out of 6. Okay? So what that's telling you is it's one number out of 6 possible. The odds of rolling a 4 are 1 out of 5. Odds are defined as the probability the event will occur divided by the probability it won't. So there are 5 possible non-4 answers, and there's 1 possible will 4 answer. So that's how they are different. Okay? So make sure you understand the difference. So let's look at odds a little bit carefully. The odds of an event compare the number of favorable and unfavorable outcomes when all outcomes are equally likely. So favorable and unfavorable. Okay, so let's look at that a little bit more. There you go. Okay, for odds in favor, notice this is just the same thing reversed. Okay, in favor is favorable to unfavorable. Against is unfavorable to favorable. So remember that difference. Okay, so find the odds in favor of stopping on a yellow. So in favor of yellow. So that would be the number of favorable outcomes would be 1. And remember we're talking about odds, and the unfavorable would be 3. So our odds are 1 over 3. And you could write it like this too. 1 to 3 are the odds. That's how you would say it. Okay, so we have a problem here where we've got to decide on something. The probability of winning a balloon dart game is 0.2. The odds of winning a ring toss game are 1 to 5. Which game gives you a better chance of winning? So if you're rushing through a problem like this, you probably would go, well, 2/10 equals 1/5, so it's the same. However, this one is probability, and this one is odds, and you can't compare those. So you've got to change one of them into the other. So since we don't know how many real answers there are, this is just the simplified version, we could take the odds and change that to probability, because this is favorable to unfavorable, which gives us the total is 1 plus 5 is 6. So now we can take that information and change that into 0.17. So because 0.2 is greater than 0.17, the balloon dart game will give you a better chance of winning. So that's a real thinking problem. Okay, one more. Find the odds against stopping on red. So we're doing odds. So we have favorable over unfavorable. Okay, so how many is favorable? There are 3, right? Blue, yellow, and green. So that's 3, and there's only one unfavorable response. So that is your odds. Okay, have a good day.